Chapter 1, Series 2. These are the contents to be covered in these chapters. Without further ado, let us get started. To know the series, first we need to know the sequence. There are various types of sequence, which include arithmetic sequence, geometric sequence, and Fibonacci sequence. These are the formulas for the sequence. The n here, it will be a running number from 1 to any numbers which you are interested. Let's say we take arithmetic sequence as an example. For the first term, the n is equals to 1. The number here, it will be equals to 3. While the second term, where the n is equals to 2, it becomes 5. The third term, while the n is equals to 3, it becomes 7. This demonstrates a sequence of the number changing in accordance to the running number of n. Now, if we talk about series, when we talk about the series in the form of summations, we are talking about the summations of a series of sequence with the running number starting from n until to the term that we are interested. Let us take this as an example. The formulas for the sequence is given as n, and the n here is a running number starting from 1 to n infinity. Based on the sequence here, when the n is to the infinity, the sequence becomes no limit. The number will increase with the n here, and this kind of sequence are known as the divergence. If you express this in the mathematical term, you are talking about the sequence here to the n to the limits. It will give you this as you substitute this with number n here, and it becomes n infinity. This is a typical divergence sequence. Let us look at another example. The formulas of the sequence is this. When n is equals to 1, you will substitute 1 to the n, you will get 1 per 2. When n is equals to 2, you will substitute 2 for the n, you will get your solutions 2 over 3. If you are looking at the situations when n to the infinity as written here, you will need to substitute this into the sequence formula, which is this. And based on the sequence here, it behaves like a fractions, where the bottom part of the fractions are increasing. Imagine this to become an infinity. Infinity plus 1 is almost same to the infinity. That gives you a situation that it is close to 1.0. And this 1.0 is a limit to the sequence. Therefore, when the sequence has a limit, it is a convergent sequence. The difference between divergence and convergent sequence is the sequence ends up to become infinity, while the convergent sequence has a limit. It is a definite numbers. This is another example of the sequence. The formula is -1 power of n. With the increasing number of n, the n will transform from an odd number to even number and then odd number. Powering -1 in the form of odd number and even number, the odd number will give you -1, while the even number will give you +1. What you see here is the sequence will transform the number from -1 to 1 and -1 and to 1 and alternately forever. this come to another state of no limit, there will be forever 1 and -1, and this is known as divergent. Knowing the concept of convergence and divergence, now we need to establish the principles of the convergence and divergence in series. The series is considered as the summations of a series of sequence, and the n here it will be a running number which can go up to an infinity. The numbers here represent the sequence, and the series actually sum up the sequence. After the summations of the series, it forms a new series. Let's say now you're talking about n is equals to 1. It will be the summations of the first term, which will give you 1. When the n is equals to 2, that means it will be the summations of the first 2 terms, which is equals to 3. When the n is equals to 3, it will be the summations of the first 3 terms, which is equals to 6, and so on and so forth. This forms a new sequence, and what you see here is the number is increasing, and there will be no limit. It eventually gives you an infinity. With that, this series is considered as divergent. Let us look at this example. The equations for the series is here in the form of 1/2 power of n. The n will be the running number starting from 1 to infinity. These numbers will change in accordance to the function here. 2 power of 1 will give you 1/2. 2 power of 2 will give you 1/4. 2 power of 3 will give you 1/8, and so on and so forth. The series is talking about the summations. That means all the sequence here is to be plus in the form of series. This form a new series. When n is equals to 1, that means you're talking about the summations of the first term, which is 1/2. When n is equals to 2, that means the summations of the 2, you will get this. N equals to 3, summations of the first 3 terms, you will get this, and so on and so forth. What you see here is the series of sequence here appear in the form of fractions, and the upper part of the fractions is always 1 unit smaller than the bottom part. 1, 2, 3, 4, 7, 8, 15, 16. Based on the trend here, you will expect the fractions become bigger and bigger. And when the number here is greater, it becomes closer to 1. So when n is to the infinity, the sequence we are approaching 1, which is the limit, and therefore it is considered as convergent. Let us try this example. This is a typical geometric series. You're talking about the function here, ar power n minus 1. The series will look something like this. The power r here will increase along the way, and you're talking about the summations of the series. In order to determine the series whether it is convergence or divergence, we will have to observe if the terms become bigger or bigger, or if the terms become the fractions, which become smaller and smaller. By looking at the function here, when your r is greater than 1, due to the increasing powers for the r, the series will become bigger and bigger in their terms. This will lead to the series to become divergent. as at the end of the day it will become infinity. If your r is equals to 1, the series now will become the summations of a throughout. When your n is equals to infinity, that means the a will have to add up for infinity times. This makes the series to become divergence because the series will become bigger and bigger, ultimately become an infinity. But if we are talking about r is less than 1, that means the r here after the power will become smaller and smaller until the end of the day you will get an r infinitely small, which is equals to 0. And in this case it is known as a convergence. In general, for a series to become convergence, the sequence that generate the term in the series must be having a limit of 0. That means when the n is infinity, the sequence term will end up to become 0 at the end of the day.